Okay, number 17 for chapter 9 review. Okay, so we're asked to graph secant. Secant is just like graphing cosine. Okay, so cosine, our first x starts at 0, right? Our normal first x starts at 0, and our first y is starting at 1, right? So really I'm just graphing these points, okay? And then we'll deal with secant later after we graph cosine. Okay, so I have to find my period. For cosine, it's 2 pi divided by b, or 360 divided by b, and our b is what's being multiplied by x, so that'd be 3. Okay, so then we get 120. So our period length is 120. So we know we start at 0, normally start at 0. And then I just set what I'm taking the trig function of, 3x, and I set that equal to 0. And then I'll solve that. So my first x still starts at 0. So I'm going to start at 0 here. And then I can add my period length of 120. So I know I'm going to be at 120 when I end. Okay, and then I want to know what's in between, right? And we just graph 5 of them. It's fine. We can keep on going, but we'll graph 5, which is 1 period length. And so I want that interval length, right? What are those dots in between? So interval length is just taking that period and dividing by 4, right? So then we just get 30. So then we count, start at first 0, add 30, 30, add 30, add 30, and we check. We got 120, so we know we did that right. Okay, and then our y values go 1, 0, negative 1, 0, and back to 1. Those are our 5 y values, right? And then we have our 5 x's that we already just wrote down, 90 and 120. So basically I'm just graphing these 5 points, right? So, but sometimes our y value changes based on, is there anything being multiplied by the trig function? No, it's just 1, so that's going to change, not going to change. Is there anything added or subtracted at the end? Nope, so that's not going to change our y value. So our y values just stay 1, 0, negative 1, 0, 1. So 1, 0, negative 1, right? So then I just graph these points. 1, 0, negative 1, 0, and back to 1. And then what you can do is you can just do a dotted line like this, right? Curvy line there to represent cosine. And then I can just switch that to cosecant. So every original zero. So even if you multiply by a and add something at the end, these would no longer be 0 if you add something at the end, but they're still going to be undefined. So these original zeros will always be undefined. So those will turn to undefines, okay? Then, since cosine and secant are reciprocals, we flip the fraction, right? So we flip these curves. So this curve is going downwards. So now the curve is going up towards that vertical asymptote. This curve is facing upwards between 30 and 90. So now it's going to face downwards. And then this curve is coming down from 120 back to 90. So now I'm going to go up when I'm going towards 90, and I'm not going to cross that. So there's my graph of secant of 3x. Okay, now key features of this function right here, cosine of x plus 45. So because that plus 45 is inside the parentheses, that's just going to deal with our phase shift. Okay, so what we do is we set what's inside the parentheses, or what's taken the cosine of, even if there's a number kind of out here in between. We set that equal to 0 for cosine and sine and cosecant and secant and cotangent. So x plus 45 equal to 0, and we solve for x is negative 45. So that means our phase shift is 45, okay, but it starts left 45. So what makes this 0 is negative 45. So this says phase shift right is 45 degrees. That's not true, because it's actually going to be left 45 degrees. Okay, our amplitude is what's being multiplied by the trig function. That is 1, so that is correct. Okay, the period is 315. Let's check on that. So our period is 2 pi divided by b, or 360 divided by b, and our b is just 1. So our period length, because nothing's being times by x except for 1, right? So our period length is 360, so not that one. Our domain is any real numbers. We can plug in anything we want into here. And we know cosine, if we were to graph it, just starts at 1 and goes down to negative 1 and then back up to 1, right? So the highest number is 1 and the lowest number is negative 1. So that would be true. So those two things, or those three things, are the true ones, the key features. Okay. Next one, phase shift here. So I set what I'm taking the trig function of, even if there's something outside in between the sign and the parenthesis, I set that equal to 0. And I solve, so x would equal pi 6th, right? So our phase shift is actually to the right pi 6th. So we want to the right pi 6th, that one, and to the right pi 6 that one. So between those two. So these ones are not true. And our period length is what's being multiplied by x, which is just 1. So 360 divided by 1. But here we're in radians, right? So that would be 2 pi divided by 1, which is just 2 pi. So that would be this one right there. Okay, last couple ones. We want to fill in the blank. We want to find our a and our h and our k. So our k is what's being added to the function. Our h is what's being subtracted here on the inside, but we have this right here. And then our a is our amplitude, right? So they kind of already found our b for us, so that's kind of nice of them to do that. So all we have to do is see where the midline is. So if we want to go our lowest point at 67 to our highest point at 75, take the difference between those two, which is just 8, correct? Is just 8, and then we divide that by 2, and that would be our amplitude is 4. Okay, so our amplitude is 4, and then we want to find where the middle is at. So if I go up 4, that would be 71, right? So here's our midline, right? So normally our midline for sine is at 0, right? Is down at 0. So how much more do I have to go up to get to this midline at 71? I have to go up 71. So there's our k, 71. Okay, h is a little bit different. We find our period length. This is the hardest one to do. So we'll go ahead and find that. So in order to find h, we need our period, right? So when does this graph start repeating itself? So we can start here and starting to graph. When does it hit that same y value and then go down, right? Because it's hit the same y value and go down. So if it hit the same y value, right here, it hits the same y value, but it goes up. So it's not repeating itself, right? So right here, it hits the same y value. So how far is it? It's kind of hard to see there. So 0 to 52. So my period length is 52. And normally to find my period, we take 360 and divide that by b, right? So if I want to find b, I would take 360 and divide that by my period. So I'm going to take 360 and divide that by my period, which is 52. So 360 divided by 52. And we get 6.9, so about 7. Well, that answer is not on here, right? So what we can do is normally we take this, and to find our first x, our very first x, we normally set that equal to 0. Okay, so because when that's set equal to 0, our first y value is at 0, and then we go up from there, right? But this graph, when we start at 0 here, because if I solve this, I still get 0. So when I start at 0 here, I'm going down, right? So I got to find my midline, which I kind of already did right here. And so this point right here is where we start at 0 at our midline, right? So we kind of got to adjust there. You got to find the midline, just like on our sine function. It starts at our midline and goes up. So since we're doing sine, we got to find that midline, see where it hits 0 and goes up, right? So it does hit 0 here, but it goes down after that. So it's not going to be that number. But this one right here, it starts at our midline at 0 and goes up. So that means that our phase shift would be 20. Our h would be 20. Okay, tangent is equal to negative 2. Find theta, and we want negative 80. So negative 80 would be down here, negative 80 to 0, negative 80. So we're looking at these two quadrants down here. Okay, so from negative 80 to 0 right there. Okay, and we want to find theta. So basically we can just do tan inverse of negative 2. So make sure my calculator's in degrees because this is in degrees. So I just go ahead and take the second tangent of negative 2. And I get that answer, and it says negative 63. So it says negative 60, we'll round to the nearest hundredth, so negative 63.43. Okay, so that means we're down here. Right there would be negative 2. So down 63 means we go down right there. So negative 63.43. Okay, and then the last one, find arc. That's just the same as cosine inverse of negative root 3 over 2. So here we don't need a calculator. We just say, what gives us an x value? Because cosine is x. What gives us an x value? What angle gives us an x value of negative root 3 over 2? So negative means I'm to the left, right? To the left is a negative on the x. And a root 3 over 2 would be farthest away. would be negative root 3 over 2. So that means my point would be somewhere out here where the y value is smaller than the x value. So that's a 30, 60, 90 triangle. So that is a 30 degrees. So that'd be pi 6, but we want down here. Or we would also be in this quadrant right here, we would still get a negative, but a positive 1/2. And so for negative, it's either some kind of 30 degree or pi 6. So we can see that. And we want probably in the second quadrant or the third. So that's either 5 pi 6 or 7 pi 6. We don't have 7 pi 6 in here, so it's 5 pi 6.